Tēnā koutou katoa, nau mai, hoki mai, to the penultimate SCANZ session. This is Thursday, 18th of November, for those who are not able to attend in person but watching the recording. Today we have a series of 3 talks, which are highly interesting and exciting. Yeah, so without further ado, I will introduce our speakers. So first up, we have Ying Yang with the power of student voice and participatory science and action. So Ying is the STEM manager at Te Honona Akona Comet. That's the charitable trust and CCO working to reduce educational inequalities for all learners in Tāmaki Makaurau, Auckland. She manages participatory science programs in South and West Auckland. Participatory science brings together schools, scientists, businesses and communities to work collaboratively on STEM research, so that's science, technology, engineering and maths, that is locally relevant and engaging for students. So kia ora, Ying. Next up, we have Davidson and Vanessa Crowe, and their talk will be on building bridges between people and nature with eDNA, the story of a community science program by the EPA, the Environmental Protection Authority. So is a science communication advisor at the Environmental Protection Authority and a postgraduate student at the Centre of Science Communication at Otago. She has a particular interest in elevating and supporting storytelling for better connections with and understanding of te taia, the environment, and a growing interest in eco-fiction and creative non-fiction. With Ham is Vanessa Crowe, who is a senior community engagement advisor at the Environmental Protection Authority. She has spent 7 years working within community-led engagement and environmental sustainability, following on from a career lecturing and practicing in design for social innovation and fine arts, with a focus on public participation and design thinking. Over the past year, Ham and Vanessa have been running Wai Tuwhere o Te Taiao, a community science program through the EPA, the Environmental Protection Authority, that offers environmental testing kits to community groups, iwi and hapu in schools. Today, they're going to share some of the stories and learnings they have gathered over this time. Kia ora, Ham and Vanessa. And finally, we will have Cathy Cole, who is giving a talk on tackling climate change through connecting communities with emerging data. Cathy is a lecturer at the Centre for Science Communication at the University of Otago, with a decade of experience both in ocean climate change research and communication of climate science. Following a PhD and a postdoctoral position studying marine biogeochemistry, Cathy spent a number of years working for the UK Met Office Climate Programme, connecting climate science with policymakers in government. Finding the relevance of emerging science for diverse audiences and delivering this information in clear and accessible media for non-specialists continues to be the drumbeat of her work at Otago. Kia ora, Cathy. So, that's our little introduction for everyone. And now I will hand over to Ying as the first speaker. Ngā mihi mai ahua kia koutou.
Thanks, Laura. Kia ora koutou. I'll share my screen. Hopefully this works. All right. Kia ora koutou. Ko Ying taka ingoa. As Laura mentioned, my name's Ying and I'm the STEM manager at Te Honga Akoranga Comet, and I look after STEM engagement and awareness. So basically we're wanting to increase engagement, participation and career progression into STEM for all the young people in South or West Auckland. So today I'm going to talk about one of our main initiatives, which is the participatory science platform in South Auckland called SCANZ, and especially highlighting some of the really cool stories that have come out of it of students doing student-led science and the power of their voices in affecting change in their communities by raising awareness and creating action around science-related topics. So before I jump into that, I just wanted to start with a question for everyone. Sorry, clicked the wrong button. What do these two have in common? So apart from the penchant for bright yellow jackets, Greta and Ronald McDonald actually have a few things in common, surprisingly. Neither of them are scientists, but they have been excellent science communicators in their own way, and they use their voices to raise awareness of science issues and influence change in their communities. So with Greta, we've obviously seen her doing her speeches and her strikes for climate change action. And Ronald McDonald, well, if you grew up in New Zealand in the 90s, like I did, you might remember the advertising campaign, Make It Click, where Ronald McDonald and the NZ Police were teaching kids about road safety and the importance of wearing their seatbelts. What these examples show us is that science communication is really broad, and it can be used for a lot of different things. And one of the positives is influencing change in our communities. And it doesn't have to be done by a scientist. This is something that we've definitely found in our participatory science programs as well, where we've seen that through collaborative science and communication, student voices have the power to affect positive changes in their communities. Before I dive into some of these stories, I'll tell you a little bit about the participatory science platform. So this is an initiative of the Curious Minds suite of initiatives for improving science engagement in society. So it's funded by the Ministry of Business, Innovation and Employment. And basically what the platform does is we foster collaborations between students, STEM professionals and community groups. We offer these project groups up to $20,000 in funding to undertake a science or design research project. And the projects often centre around a question that they want to solve or a problem that they want to solve in their community. The projects will last for 12 to 18 months, and we really encourage that long-term partnership building between the different collaborative partners. The PSP has been running in 3 regions across Aotearoa. And since 2015, SCANZ has funded 65 projects and engaged well over 3,000 kids in the South Auckland region. The first example of a SCANZ project I have today is sorting out our rubbish. This is done by Le Malelenga, Le Tole ECE. This is a Pacifica early learning centre based in Mangere in South Auckland. And they wanted to learn about waste management and pollution in their environment. So the centre worked alongside design engineers from Fisher & Paykel Healthcare, and they worked to design and build these rocket ship rubbish system. So there's a set of 3 coloured bins that help teach the kids about sorting their rubbish, food waste and recycling. What was really awesome about this project is the hands-on nature of the building and designing and prototyping really engaged the kids. And even though they're very young and they didn't know all the terminology, they were really able to latch on and understand what they were trying to do and why they were doing it to sort out their rubbish. And it really helped to increase their skill in sorting rubbish and identifying different types of waste. They've now been able to spread that zero waste message across to all their whānau as well in the community. And I've got a little quote there from a parent who was just really surprised at how much her 2-year-old had actually learnt and how much he was teaching her as well. And the other cool thing about the project is these bins will stay in the classroom and they'll be used as a teaching resource. So as different kids move through the centre, the older kids will be teaching the younger ones about waste management and sorting their rubbish as well. And through that, we hope that the zero waste message will continue to spread in the community. The next project I'm going to talk about is raising the awareness of water quality in the local awa. This was done by Accelerating Aotearoa Inc., which is a community group based in Otara. So Accelerating Aotearoa, they do a range of holiday programs and after-school programs called Geek Camps, and they teach kids about STEM in locally relevant ways. Over the last sort of 16 months, they have been doing investigations into the water quality in their awa and looking specifically at what happens when it rains and what wastewater overflows occur in their area. What they found was actually really shocking. There are wastewater overflows that occur very frequently with only very small amounts of rain. And obviously overflows lead to contaminated streams and harmful levels of E. coli and other nasty bacteria and stuff in the water. So the kids were really determined to do something with this knowledge and to warn others of it so that they don't get into the streams and get sick from the contaminated water. As you can see, they got creative and they put up signs. These were colourful signs all around the neighbourhood or along the stream and in their local library as well. And they also did some social media campaigns to promote this message. What's really cool to see is that like Otara is a bit of a rough neighbourhood. There is vandalism and stuff happening, but after a few months, the project lead said she was really surprised the signs are still perfectly intact and they really seem to have been adopted and the message seems to have been taken up by the community, which really shows the importance of these student voices displaying their own messages in their own ways. Another awesome part of this project was that some of the older kids, the rangatahi, decided to run their own workshop and teach students from other schools in the area to test water quality in their local streams as well. So they used a tuakana tēnā approach. The rangatahi basically organised and ran the workshops entirely on their own and were really empowered to be the scientists in the situation and teach other kids about the science of water quality monitoring. And this is just really awesome to see. We're hoping to see this roll out across a number of schools and adopting their own streams in the Otara region. My final project that I'll explain is from Manirewa High School, and they were looking at how to make housing more affordable. So the Manirewa High School math students worked alongside AUT mathematical modelers and Auckland Council planners to identify the different factors that influence housing price and why it's a crisis and what could be done about it. And they focused especially on how to make housing more affordable for large, low-income families that are quite typical in Manirewa. So the kids came up with a range of recommendations, including bigger houses for bigger intergenerational families. They wanted to have better housing quality so that there would be privacy even though they wanted to build denser, and also better access to public transport for people who needed to get to jobs. The really cool opportunity for the kids came up to actually present the recommendations to the Auckland Council Urban Planning Committee. So they went to the town hall in Auckland and they presented their findings to the Mayor, Bill Goff, and a whole range of policymakers, decision makers, etc. This was a hugely rewarding experience for them. A lot of these kids never even go into the city. They've probably never been to the town hall and certainly never had the chance to talk to such important adults and really voice their opinions as well. And although unfortunately they haven't fixed the housing crisis, I think it shows that it's really valuable to have the student voices participating in this conversation. They were able to offer really locally relevant ideas and solutions, and they were able to voice what was important to them and their communities as well. So those are my 3 examples today of student voices and participant in science. And I'd really love to encourage more students to be involved in the science and in influencing those changes in their community. So how do we do that? Through Southside, we've learned a couple of lessons, so I'd love to share them with you all today. As a school or an educator, you can listen to your communities and students' needs and really find what works for them and what they want to do and let them lead the way. Create authentic, relevant learning experiences, collaborate with external experts to use their knowledge and leverage that knowledge for creating solutions, and empower the students to direct their own learning and share their own stories in the way that they want to share them. As a scientist or a science communicator, we could be supporting schools to explore science outside the classroom, contributing the knowledge that we have and being a role model for students. You can also work alongside your communities when planning and undertaking research, and make sure to recognise the value and the strengths that community partners, including students, can offer. It's really through that collaborative lens of working together and utilising each other's knowledge and strengths that we see these relevant and locally important science sort of solutions come about and really help the students to empower them to do that. So I will finish off now with a whakatauki that sums up the collaboration that I'd like to encourage in all my participatory science projects. No te roro, nā ku te roro, ka ora ai te iwi. With your food basket and my food basket, the people will thrive.
Kia ora, Ying, thank you very much for that. So as I said earlier, if you want to put your questions down into the chat box as we go, and then we'll just ask them all to everyone at the end. Next up, we have Ham Davidson and Vanessa Crowe, Building Bridges Between People and Nature with eDNA, the story of a community science program by the Environmental Protection Authority. Over to you.
Kia ora koutou, ko Vanessa Crowe toko ingoa. I'm joining you here from Wellington and the Environmental Protection Authority's office. And it's great to be here to share this program with you. This is something that Ham and I have been working on for the last couple of years. It was about this time last year that we launched and invited community groups, iwi, hapu, kura and schools to take part, and we were quite impressed and amazed to see we quickly had about 200 registrations by the beginning of this year. So I'll just move on to the next slide and just share our thinking behind the program. So the program is based on a community-led model. We want to offer kits out to groups across Aotearoa and give them the agency and choice about how they might use these kits in terms of where they want to take samples, encouraging a place-based connection, encouraging groups to connect with New Zealand Landcare Trust advisors and councils in their areas. And we have been supporting that. And also, it's not just about science, it's also been strongly about storytelling. So we've been working with groups to explore how eDNA data can be meaningful for them. So I'm going to hand over to Ham to share a bit of the science with you, and then we'll also talk about our storytelling efforts as well.
Yeah, so as Vanessa has said, Waituwhero Te Taia is based around the exploration of environmental DNA or eDNA, and this refers to all of the tiny traces of genetic material that's left behind when living things pass through water in their environment. So from kereru to kōwhai and the leaves in the wind, all living things shed genetic information into their local environment. So if you take a lake, for example, a bird might perch overhead and drop a feather, and under the surface, a fish is swimming around and shedding off sliminess. If it's unlucky, it gets gobbled up by a bigger fish and excreted. An insect's eggs might fall into a lake as leaves and pollen fall from trees. And all of these plants and animals, and even microorganisms that we can't see with our eyes, leave behind these genetic breadcrumbs in their environments that they live in. So if someone comes along and scoops all of that up, scoops the water up and then traps it on a filter like that blue one you can see on the end of the syringe there, a lab like Wilderlab, who we collaborate with Waituwhero Te Taia, can isolate and feed all of those little breadcrumbs into a machine called a sequencer that spits out codes that are unique to all of the different organisms in the mix using their DNA. So then these can be matched to codes in a database to figure out where those breadcrumbs came from. So this provides a picture of the whole, not only the whole biodiversity, not just in the lake, but also the whole ecosystem dynamically, from mammals to fish and algae and birds and even smaller things. So it provides this presence and absence data, so whether things are there or not, but also a way to appreciate how interconnected our ecosystems are, and there are just so many implications that can come from that. Application, sorry. So this concept of collecting up these genetic breadcrumbs and finding out where they came from in order to learn what has been in and around the ecosystem has resonated really well with participants, from school kids to iwi and hapu kaitiaki to old farmers in gumboots. It's a way for people to engage with science and place in a new way alongside their local context and knowledge, or their mātauranga, and allow them to explore environmental data and science in a context that's meaningful to them. So I'll hand back to Vanessa now to share a little bit more about what the results look like when they get them, and the story from there.
So we're going to share some links with you in a moment, but participants send their water sample to Wilderness, and about 6 weeks later receive a report which shows all the species which were present in the sample. And this report is similar to what you're looking at on the screen. It is also connected to an interactive map that Wilderness have, and you can go in and explore the publicly available data there to see what types of tests people have been doing across Aotearoa. As we were designing the program, we worked quite closely with some of our iwi and hapu partners who are part of our Te Herenga network, so that we could build a program that was good for Māori, good for people who had any concerns around the way that their data was being shared. So the data on the map is protected with a password when you first receive it, and then if groups opt to make it public, they can do so, and then everyone else can see it. What's sort of really interesting about these reports, I think, coming from a non-science background, but with a big interest in our environment and in engagement, is that these reports show the environment in quite a holistic way. It shows the species which are present that we know about, and here you can see the report has a link to Wikipedia, so it's really easy, accessible data for everyone and anyone to look at. And then it also provides on the right hand side, the sequence info. That data actually goes on and on and on, and it starts with the most known species, and then it kind of moves into genesis, and then just A, C's, T's and G's. So there's a lot of data there that actually has not been sequenced yet, and I think it tells a really good story about how science is not just a black and white thing. It's a kind of an unfolding of knowledge which happens over time, that we are continually learning more and more about our environments, and there's all sorts of different ways that this information can be presented. The important thing is that it's meaningful for the people who own the information. So this is a wheel of life which Wilderness has created as one way to present the data that makes it super accessible and easy for people to see and understand. Here, all of the species that were present in a sample are presented according to what type of species they are in a scientific order. Wilderness has worked with us to develop a tutorial which we have been sharing with groups participating in the program, so they can go and create their own wheel of life. And one cool offering that they've given is they've created about 400 of those silhouettes that you can see of the different species. So as new samples come on, their designers create more silhouettes, and we've shared that folder with all of the participants, so they can go and create their own version of this. We've developed a tutorial that just uses PowerPoint to do so. So what groups are telling us is that this is meaningful, but for others, they want to present it differently. For them, it's about showing native species or showing pests or showing mahina kai. So it starts a conversation about how do you want to show your data? What's important to you? What story is important to you? So this sort of leads into talking about the kind of communication side of this program. So we are really focused on how eDNA can be a tool for connecting people to the environment. As the Environmental Protection Authority. We are the national regulator. We set the rules for a lot of activity that can happen in New Zealand, but we also want to step out and have a role as influencers, raising the bar for environmental protection in a place-based way. And we need to be able to connect with people outside of our office in Wellington. The more that we can establish ongoing relationships in every part of Aotearoa, the more people can ultimately participate in our processes, and particularly so with iwi and hapu, who we have an obligation to consult with and work closely with. So this program has actually offered us something that we can offer to them, which is not something that we're asking of them. It's a really useful tool that is locally specific. So the program has over 200 participants. We've sent out 400 kits. We've collaborated with regional councils, New Zealand Landcare Trust, and our Te Herenga network. We've done a lot of online engagement. So over 50 at least Zoom huis with different groups, 10 organised webinars providing sort of education and resources to all the groups participating, and 5 hui kanohi ki te kanohi, so that's a place-based workshop or hui. There would have been a lot more of them if it hadn't been for COVID, but on the other hand, COVID's been a bit of a silver lining in terms of that we're so used to online engagement now that that's really helped us to establish a lot of relationships across the country that I don't know if we would have done such a good job with it pre-COVID times, where we may not have been as confident to just jump online and connect with people that way. So as I was saying, storytelling is super important, and I'm just going to hand back to Ham to tell you about how we have been both shining the light on the cool stories that have come from the program, the actions that groups have taken once they've had some evidence from their waterways, and then the way we're encouraging them to share their stories as well.
Cool, thanks Vanessa. So yeah, as Vanessa just mentioned, we've really wanted to centre storytelling as a key method for participants to share and contribute information, and to kind of synthesize all of this new scientific information that they're gathering and to use that to inform what they're doing next. So as the participants get their results, we've been working alongside them to support them with their data interpretation and supporting that storytelling aspect as well, so they can shine the light on the awesome mahi that they're doing. To share their stories, we've been featuring groups and articles for our monthly pānui or newsletter, but we've also been dabbling in running tutorials that offer visual ways for the participants to present the information in their own voice. One way we've offered this is through a digital storytelling platform called Story Maps, which uses maps alongside GIS maps alongside other media like images and text and videos. So we've recently run some workshops using story maps and some basic story structure tools to help participants to tell their story in this way. This is one way to tell it, but it's a tool that we can offer. And this one that's just cycling through the background here is from one of our pilot groups. So we're really looking forward to seeing what the participants come up with. We're also at the stage of pulling together our own stories to knit together the ways that participants have used eDNA all over the motu, and the connections and relationships that have arisen as part of this. So I think that's about all we've got time for. I've popped in the chat some links to those community feature stories and to the map and some more information. And yeah, thanks for having us here. It's been really great to hear all of the presentations, and looking forward to Cathy's one up next.
Kia ora, kia korua, ngā mihi. Great talk there from yourself and also from Ying, of course. Lots to unpack. Fantastic. Yeah, so without further ado, I'm now going to hand over to Cathy Cole, who is giving a talk on tackling climate change through connecting communities with emerging data. Ngā mihi nui, over to you.
Thank you for the introduction, Laura. Tēnā koutou katoa. It's a great pleasure to be here, so thanks for having me. And my talk today is about tackling climate change through connecting communities with emerging data. And I think that it's really important that we are connected with data when it comes to issues in science that affect us all, such as climate change. I think it's really important for building trust with scientists and with the scientific process, and also for helping us to understand the reasons why we're addressing certain issues. And the COVID-19 pandemic over the last few years has been a really good example of this, where we've all been quite connected with data about the case numbers globally, but particularly in New Zealand, where it feels local to us and where the issue feels really immediate. Climate change doesn't have such an immediate feel for many of us, though it's incredibly serious and it is a very immediate threat. And so perhaps if we were a bit more connected to that data, we might feel that more immediately. So I wanted to focus this talk on the ocean, because the ocean is really at the heart of our changing climate. And a lot of the changes that are underway are largely hidden from view, and that's partly because it's just physically separated from us by the ocean surface. We can't see what's going on below, and even if we could see it, we might not obviously see the seriousness of the changes underway. Something that shocks me every time I hear it is the fact that the oceans have absorbed more than 90% of all of the heat energy that's been trapped in the Earth system as a result of greenhouse gases emitted by human activities. And so I'm just going to show this circle represents that heat uptake by the ocean. If you just compare it to the amount of heat that's been taken up through warming the air, our atmosphere, just 1%, 3% has gone into warming our continents, so the land, and about 3% has gone into melting ice, so our Antarctic and Greenland ice sheets and glaciers on land and sea ice. So the oceans have really borne the brunt of taking up this heat energy, and they've also absorbed about a third of all of our carbon dioxide emissions. So they're right at the forefront of our changing climate, and they're protecting us from a lot of more faster changes that we would otherwise see on land. But it's not without a cost, and there's the impacts of this and are just not so visible. There was a study in 2012 that asked New Zealanders what they perceived the greatest threats to be in the marine environment, and the top two came out as being plastic pollution and industrial fishing. But actually the greatest threats, the biggest threat is ocean acidification, and the second one is warming sea temperatures. So that just illustrates the kind of less visible nature of these issues. And I wondered what's the reason for these being less visible, and I think it really just comes back to the fact that they are less visible. We don't have the same kind of visual images that portray the seriousness of those threats. So this project that I'm involved with is not meant to be adding further horror to our lives through more horrific images, but it's just really got me thinking that if these issues were more engagingly presented, would we have a greater collective ambition to act to address our ocean climate crisis? So it's really exciting being in Otago. Otago actually has some of the longest ocean climate records in the whole of the Southern Hemisphere. So we have this treasure trove of ocean climate data. This image is of the Portobello Marine Lab, which is in the Otago Harbour, and they've been collecting sea surface temperature every day since 1953. And there's also the Manida transect just offshore the North Otago coast, which measures ocean, a whole range of ocean parameters, but things like pH and dissolved carbon dioxide in the surface ocean. And they've been doing that every season since 1998. So this is really, really important data, and it shows really stark warming and acidification in our local ocean. But those data sets are really not very accessible. So some of them aren't available online, or they're not available publicly. And even if they are, they're often in quite technical formats, or they're difficult to download and process. So it's not information that's really accessible. And so I asked for some funding from the University of Otago this year to work with community groups to look at some of this data and think about how we might bring it to life a bit more. One of the ways that we did that is by looking at how we can give story to that data. So connecting the physical data with some of the impacts on marine species that we really treasure locally. And there are so many stories here. And so we explored lots of published data, both that physical data and also marine impact data. And all sorts of things came up. So Hoi-ho, the yellow-eyed penguin, nests on the Otago Peninsula, and they're in very serious decline, but they are, there's lots of different threats to Hoi-ho, but there's a very considerable link between years when there's a warmer ocean, there's greater mortality of penguins, and that's partly because they feed on fish that in warmer seas dive to deeper depths, so they're less accessible for the penguins. And then about 80% of all of our marine life starts out as plankton. So this very, very vulnerable stage where they often have shells that are maybe more vulnerable to dissolution, or they are dependent on developing using environmental cues that were evolved in a cold ocean. So small changes in temperature and pH can have a huge impact from these very, very early life stages all the way up to species that we consider to be really interesting and help us feel like we're living in a beautiful, healthy, diverse world, as well as being a food source as well. So there's a lot of stories behind this data, and we thought that perhaps if we used some of these to illustrate that physical data, it would bring it to life a bit more for people. So we had a whole range of creative workshops which began during the Science Festival in July in Dunedin City Library, and then we had a few more recently out at the Marine Studies Centre in Portobello. And this was just a really great opportunity to get together as a group for a whole day and explore that data. And we toured the marine labs and looked at some of those plankton species under a microscope and talked about the impacts that they were facing. And then we just spent some time doing some artwork. So we had Virginia Watson from Dive Otago, who's a professional printmaker, and she guided us to make some prints. And we also did watercolor painting and drawing and writing, and just had a play with the data and to see what we could come up with. It was a really, really powerful experience, and almost everybody said that they didn't have any creative or artistic talent, and that just turned out not to be true. So I'm really excited to show you a couple of the artworks that we produced as a result of this. So this is Gianna Savoy's The Rise of the Jellyfish, which illustrates this rise in ocean temperature. So the waves are showing that those warming waters at the same time as showing a change in the species assemblage from this really beautiful, diverse range of creatures, lots of calcified shells, to something that's a bit more dominated by jellyfish. And then Jen Rogers created this beautiful piece that had the story of the gulls, the tarapunga, who feed on krill, which live in typically cold waters, and the gulls can't actually dive to feed, so they have to surface feed. And during warm events, the krill move to deeper waters, so they're not accessible to the gulls, and they have real issues foraging for food. This is another example. This is Francis Perez, who beautifully shows how there's this dichotomy in places like Otago, where we actually see a warming ocean potentially as being quite a good thing, because it means that we can surf more easily or more comfortably, but actually what's going on beneath the waters. And she shows this story of decline in species and reduced diversity, which is really worrying. And then just the last example for today, Janice Huang illustrated some winter temperature data for Dunedin alongside some of the species whose larval stages are really influenced by temperature. And it's just a really beautiful piece of work, and I think it invites questions about what that data is showing a lot more than looking at the data on its own. So we also had a bit of a survey where I asked participants like what they learnt or how they found the whole experience. And really interestingly, only one person out of everybody who came to the workshops had ever heard of these programs to collect this ocean data. So that kind of reinforced this view that it's not very accessible, people don't know about it. And everybody said that they felt like they understood the data more after they worked with it and created an artwork. So that was really interesting, and we're going to be doing a bit more research around that. But really just wanted to show that we've put all these artworks together into a published calendar for 2022, which I'm really proud of. And each month has an artwork alongside a story about some of the creatures that are affected by certain changes. But it also has some positive messages about what we can do now to help protect our ocean. So hopefully it's not just showing another problem, but it's empowering us with knowledge about how our local ocean is changing, but also how we have power and knowledge to protect it in various ways. So you can actually, if anyone's interested, you can purchase one of these calendars for $10. I've just made a website which is going live today, so that's exciting. You can hopefully look at that or just email me. And all of the money raised from this is going to two really wonderful nonprofit organisations, RC's Our Future and Ocean Media Institute, who both do incredible work in both education and conservation around the ocean. So I just wanted to thank everybody who's been involved, and I'd love to have any questions.
Thank you very much, Cathy. Yep, so what is the website, please, I think? So Cathy, if you want to just type that in the chat, and then everyone can see that. So yeah, if you have any questions, don't forget to put them into the chat. I think we should get the first one coming through. I actually want to say how wonderful it is to see all the great images that all of you have used in your all three of your presentations today. It's been fantastic actually getting a real visual sense of you know, how you're working and what's happening in your work as well. I am just waiting on the first question. I think there was one for Ying. Oh yeah, so for Ying, what kind of support does COMET provide to these groups? And that's from Phoebe Drayton.
Yeah, so COMET is the manager of the PSP Fund in South Auckland, so we support the groups to actually come up with their project idea, you know, elaborate on what their problem is and help them to find connections with scientists or other people, other experts if they need it. And they go through an application process. They tell us what their idea is, what they're going to do, and we assess it. And if it meets our criteria, we'll fund them up to $20,000. And then we support them throughout the project implementation with various like mentoring and helping them to, often it's about connecting with the scientists or the STEM experts and looking at ways to increase that collaboration, and also helping them to share their stories. So we have events throughout the year where students can come and they're presenting, or they're doing a film festival and they'll show their videos of what they've done, and really helping them to share their stories wider so that they can create more change in that community.
Thank you. We've got another one as well. So we'll just do two per speaker. That saves us just going around too often. So the next one is, I wondered if the resources or ideas that the students create are shared with people in their positions to drive change. So can you tell us a bit more about that, if there are any?
Yeah, so it does depend on the project. We have had projects that work directly with local boards in the area, so the local board is really active and takes on some of those suggestions and recommendations, or at least, you know, acknowledges the findings. We have projects where they might go on to expand some of what they're doing, and then it can become a more national sort of thing. I'm thinking more of projects in Taranaki and Otago in that sense. They've been able to expand some of their community projects, which is really cool. And we also do share, like I say, share our stories with people. We have events where we invite like the mayor and the local councillors and stuff like that, and give them a chance to see what the kids are doing. And that's really the main way of getting the ideas out there.
Thank you. Yep, so our next question is for Ham and Vanessa. Comment, this is awesome. Did you find any DNA that couldn't be matched to anything? Potentially maybe a new species? And that's from Georgia.
Yeah, so in those sample reports that the that the participants get, you have all of the species that are known and are matched, and then you scroll down and there are actually heaps of ones that aren't matched. And so you can kind of get an idea of maybe what family or broad category that they belong to, but because the reference databases aren't complete, then there'll always be this kind of, as long as eDNA is going, this kind of living progression of more species being discovered. So there could be new ones in there, who knows? Yeah, could be some unknown galaxid or something. Yeah.
On that note, also, what's interesting about those reports is that the way that World Lab has set their database up is that the reports will continue to update as new species are sequenced. So you can go back and look at that report, in a year's time, and it probably will have more information there. One of the other thing, it's not like a new species, but eDNA is really useful for picking up notifiable organisms. So that's one thing that MPI is linked into with World Lab. If any notifiable organisms come up in a sample, then they will be alerted. So it does sort of have some biosecurity potential there, which is pretty cool. And sometimes random things come up, like one time famously a kangaroo came up as one of the DNA species, and that was very surprising, and had to do a wee bit of detective work, and it turned out that, I think, was it on the Miramar Peninsula?
Yeah.
And they realized that they sold dog food with kangaroo meat in it at the local supermarket, and so there was dog DNA in the sample as well, so it was most probably from the dog poo. So it is highly sensitive in that way, and occasionally it requires quite some creative thinking and detective work to actually see where some of the surprising DNA might come from.
That's absolutely fascinating, and yeah. I mean, it would have been quite a job to try and figure out where that kangaroo had come from. That was very random. Yeah, one more question for you as well at the moment. How are you funding this mahi, and what channels did you use to market this project? And that's from Phoebe.
Well, our funding came internally. So from within the EPA, we have what's called a program of work, where we run pilot programs to, essentially get something new established or try something out that then kind of becomes part of our day-to-day work. So we had some funding to do that, and then we're from here looking to potentially partner or access other funds to be able to keep offering the kits out to groups. In terms of the marketing of the program, we didn't really do much marketing. I've just been thinking about that since I saw the question, because we can't, as a government organisation, we don't have a huge budget to pay for advertising. What we did do was we spent a long time really getting the bones of the program right. We got up our website with really good, kind of easy to understand information, and then when we launched the program, we put a call out for participants to register their interest for 3 months, so they could go to our website, learn about the program, sign up, and we shared at our launch our program with all of our sort of existing partners and interest groups. So that's where councils and like New Zealand Landcare Trust, for example, found out about it, and they actually shared it on and on and on, and it just took off. Like we were quite surprised at how many participants we had signing up in that time. Yeah.
Yes, awesome. Thank you very much. Also, go ahead. Yeah.
I was just going to say, yeah, we did do some like snooping around on what community groups on Google we could find as well, and then also one of our team members spent a long time doing phone calls to members of a Te Herenga network, and that was a key way of getting the iwi and hapu involvement as well.
That was fantastic. It's very good to actually have an example of something that you can do really well without much budget at all. So fantastic. So yeah, thank you very much, and we'll roll to Cathy, and then we'll just keep circulating back, and depending on how many questions we have left. So for Cathy, how can we roll this work out to other regions? It's really cool, and that's from Georgia.
That's a great question. I actually think that potentially through networks such as SCANZ, that might be a way that we can do it. I was thinking that the National Science Challenges are quite a good way for trying to capture this kind of activity on more of a national scale. So using some of the contacts that they have, places like, I was thinking the Deep South or Sustainable Seas are two ones that spring to mind that maybe could help do this kind of thing. Because when I first had the idea, I wanted to do it for all of Aotearoa, and then I was told that was way too ambitious, start with Dunedin. Which I think was good advice, but and it was really, really amazing to see how people got involved with it, and everybody said they'd like to do it again, and so trying to do it in different regions I think would be really powerful, because ultimately I was thinking it'd be really cool to have a kind of like almanac to the seas of New Zealand, where we are celebrating our marine life but also showing where we're vulnerable around the whole coast, and having stories from anyone who wants to contribute would be really, really cool. And it could be something actually that could be done online. I think it was really interesting, Vanessa was saying about the opportunities that COVID has brought in terms of connecting with people that you wouldn't necessarily have been bold enough to reach out to online, and now it's so normal to be doing that, so actually trying to arrange these kind of things virtually might be a really good idea.
Awesome. And yeah, again for you, from India, what was the response of the people in the workshops to all of this data, which can be quite overwhelming? Did they feel depressed by it, or did working through it through art seem to help them process it a little bit more positively or constructively?
Yeah, that's a really good question. I think that it's really, really easy to end up feeling really depressed about climate change, and especially ocean changes, because a lot of the changes are quite, it's quite a long process. So things, once certain changes are underway, they're quite difficult to reverse. And the key message really is that I think that this decade is almost like our final chance to act to reverse this, because we've reached a point where there's a lot that we could do if we all collectively decided to do it today, but we're running out of time, and if anyone was following the COP26 discussions over the last few weeks, which are always quite frustrating, but we're recognizing that we are running out of time, and that one of the things that came out of that is that we can't be waiting 5 years to be ratcheting up our ambition. It needs to be every year. So that was one of the positive things, and I think that we have to focus on what we can do and not on the doom stories, and what we can protect by taking small actions. So it might be that we can't save everything, but if we do this, we might be able to actually protect this important thing. And a lot of the issues with the oceans is that there's so many multiple impacts going on. So as well as climate change, there is pollution, and there's all different ways that we use the ocean environment, and we can really minimize that risk by knowing a bit more about it. So it's all a bit about just helping people to see what's going on, because if we knew about it every day, then maybe we would all be really encouraged to take action rather than kind of letting it stay hidden.
Thank you. Yes, it's quite a lot of science communication actually is around yeah, a lot of stuff that's just out there all the time, and then people don't realize that it's happening. And yeah, thank you for that. We do have just one more question. That's for Ham and Vanessa. How long does the eDNA stay in the environment? So for example, how far back in time can you detect presence of a species? So for a minute there, I thought the kangaroos might have been from before or something, but obviously not. So Gondwana, I don't know.
Yeah.
Yeah. How far back can you trace that, and how long does it stay in the environment?
So with these methods, getting it from water on the filter it's kind of a matter of hours to days. It doesn't last very long in the water column because of all the other like UV light and other biological things going around and gobbling it up. So it is quite a snapshot in time when you take a sample and get that report back. But there are other ways that people can get ancient DNA from things, but in this program it's just
Okay. Yeah, so if I don't think anyone else has any questions, just a lot of comments just saying how great all the presentations have been, and just from Jana, such an inspiring group of presenters, thank you all. So with that, I will just wrap up. So just to let you all know, yeah, so there's an opportunity coming up at SCANZ to join the executive committee, and we're just in the middle of like pulling that together and creating roles and things for specific people and skills, but you don't have to have previous experience. It's just as much to support, you know, your own growth as well as ours. So yeah, and they will be out in due course, hopefully for the end of the year, but we'll see how busy it gets. But yeah, so please do keep an eye out on your inboxes for those if you are keen to do things like organise a conference and get speakers and workshops, and even just organising the networking nights, things like that. So we, yeah, we'd love to have you on board. So tomorrow we have a drawing a science panel, and that's very exciting. I'm very excited to see what that is. It's participants of the spin-off and the Science Media Centre's drawing science workshop. So that was on the back of last year's talk. We had the keynote was Susie Wiles and Toby Morris, and not saying it's from that or anything, but everyone recognised how cool it was to have art and science together to communicate quite complicated messages around health and other topics. So that drawing science workshop was on the back of that. So they just paired scientists with artists, from my understanding, and I think there was about 30 participants, and they all just collaborated to see unexpectedly to see what would happen. So tomorrow we have our panelists, Margaret Stanley, Killian Kearns, Hima Kumar Devan, and Pepper Raccoon, and that will be chaired by Science Media Centre. And oh, it was inspired by the SCANZ talk, Dacia says in the chat. The idea came directly from hearing Susan and Toby present last year. Well, that is fantastic. Yeah, and then that session, that panel will be followed by the announcement of this year's SCANZ Award winner in runner-up. So here and all, see you back here tomorrow at 12:30 to 1:45, just to include the award ceremony. Ngā mihi mai hoa, mā te wā kia koutou.